Hey guys, I just wanted to do a quick example of the sailboat problem. So here's our situation. We have a sailboat that leaves the pier due west at 8 knots. After 15 minutes, it changes course to north 16 degrees west at 10 knots. And we want to find the bearing and distance from the pier after 12 minutes on this new course. So I've drawn out a little path that our boat's going to take. It's going to travel in this direction due west for 15 minutes at 8 knots, and then it turns north 16 degrees west. So here's my north direction, this right here is going to be 16 degrees, and then we speed up a little bit and go 10 knots for 12 minutes. So 12 minutes at 10 knots. And we are looking for the distance from the pier. So here's the pier. We're looking for that distance. And then we're also looking for the bearing. So that bearing is going to be made with the north in this direction. So that's the angle theta that we're looking for. And I can already tell that this is going to be some sort of a north, some sort of degrees west answer, since that's I am northwest of where I started. So the first thing I want to do is get some side lengths for this triangle. I'm going to use my 15 minutes at 8 knots. 15 minutes is 1/4 of an hour, and at 8 knots per hour, that's going to give me 2 nautical miles for this side length. And then 12 minutes is 1/5 of an hour. So 10 knots for 1/5 of an hour is also 2. So this right here is 2. So let me take out this. And so now I have 2 side lengths of 2 miles. The second thing is to find an angle, and really the only angle they give me to go off of is this 16 degrees here. With this right angle with the north and east-west direction, 90 degrees, will make a total of 106. So I'm going to take that angle out and put 106 degrees here. Okay, where to go next? Well, I recognize that this is an isosceles triangle. So if I use my isosceles triangle properties and draw the perpendicular bisector, right angle right here makes a nice right triangle. This 106 degree angle gets split equally, so 53 degrees here, and since all three angles add up to 180, this angle would be 37 degrees. And if that's 37 degrees, my theta would also have to be 53 degrees, because of the fact that here is another 90. So I've already got my bearing, north 53 degrees west, as one of my answers. And now I need to find the distance. Well, in this right triangle, I know that this side length is 2. That's my hypotenuse. And I'm looking for this edge here to this midpoint. I can find using my cosine function. So I can set it up as the cosine of 37 degrees will equal the adjacent side divided by the hypotenuse of 2, and multiply both sides by 2. So I have the cosine of 37, which will give me the distance, and that is, in my calculator, 2 cosine 37 in degree mode, got 1.597. So that's really about 1.6 to 2 places, 1.60. Okay, that is just this little piece, 1.60. And my hypotenuse, or not my hypotenuse, but my full distance is actually double that. So I will just multiply by 2, and I get d to equal 3.2 miles. There we go.